Organ transplant is the replace of human organs with different objectives. For example, the most used materials to prepare the human like organs are biomedical polymers. And polymers are well known for they are well resistant to electricity. But some of the polymer can conduct electricity. They are called conducting polymers. And today our topic is biomedical and conducting polymers. So, what is biomedical polymer? Biomedical polymers are essentially made by biomaterial which is used in application of medical field. They are prepared by the biomaterials and prepared materials can be applicable in medicinal field. These type of polymers are called biomedical polymer. Initially, biomedical polymers are prepared by the biomaterials only. That means from the living organisms. So just like cellulose, colgan, cytotone, etc. But nowadays, biomedical polymers also prepared in synthetically. So example biomedical polymers are natural biomedical polymers are colgan, cellulose, alginates, dextrans, and chitosan. But synthetic polymers we can prepare in the laboratory. Those are polytetrafluoroethane (PTFE), polyethylene, polypropylene, polymethyl methacrylate (PMMA). So metals in maxillofacial prosthetic also used in the synthetic polymers. So, what are the properties and applications of these biomedical polymers? So, first of all, properties they should be flexible. Why? Because they are going to replace the human organs. Human body is a mobile, and there is so much pressure in the body. So, it has to bear that pressure, and they should be flexible for different types of movements. That's why the prepared materials should be flexible. The biomedical polymers should be flexible. So and they should be great resistance to biochemical attack. Why? Because our body having different types of bioorganisms, so they will not interact and they will not destroy by attack of bioorganisms. That's why they should great resistance to biochemical attack. And they're lightweight, easily manufactured into item, into good shape. Why? Because the perfect 100% perfect shape required, exactly it replace the replica to the our organs. So if anything is not perfect, it will create different problems in our body. That's why it should be lightweight and easily manufactured into desirable shape. Okay. And good biocompatibility and non-toxic and non-inflammatory. It will not create any problems in our body. It will not create a inflammatory. So it if it is produces any toxic gases, it is very better to use. And application we can use in medical disposals, dental materials, implants, synthetic bones and valves, dressing materials, tissue engineering materials, controlled drug delivery systems. Just like this, you can prepare the artificial bones, artificial skins, bionics, and plastic surgery, photo and prostheses. And these are the useful in different fields. We can make artificial bones, artificial legs, artificial ears. So different types of applications is there in medical field. Nowadays this area is increasing enormously. uh, we can replace the human organs by using biomedical polymers. The next one is conducting polymers. The conducting polymers are organic polymers that conduct electricity. The main property of conducting polymers are they can able to conduct electricity. So these are two types. One is intrinsic conducting polymer and doped conducting polymer. Intrinsic conducting polymers means they are pure organic polymers which having the conjugated double bond. Conjugated double bond means pi bond is delocalized. They will not stable at one place. They are moving throughout the molecule. This movement can generate the passage of the electricity. They are responsible for the conducting of electricity. Those are pure conjugated double bond organic polymers are called intrinsically conducting polymers. If the intrinsic conducting polymer can be doped with different metals, then they are called then they are called doped conducting polymer or extrinsic conducting polymers. So we can make defects or deformations in the polymeric chain by doping with other substance. We can dope in different ways. So those one is redox p doping. When some of the pi bonds are oxidized by treating with polymer with an oxidizing agent. First of all, take a intrinsic conducting polymer. They have a conjugated double bond. When you add a oxidizing agent mean it oxidizes the other substance. Here other substance is polymer chain. So conjugated polymer chain. Conjugated polymer chain involved in oxidation. When a substance involved in oxidation, its oxidation number increases. That means it have a positive charge. So that's why it is called p doping. P stands for the positive. So this is called redox p doping. By adding some of the oxidizing agent, we are making positive charges in the material. This is called p type doping. So next one is redox n doping. When you add some reducing agents reduces the polymer chain. Reduction means it accepting electrons. When a substance accept electron, it get a negative charge. That's why it is called n-type doping. So it is the same p-type and n-type doping can also done by electrochemical method. In above method, we are using chemicals, oxidizing agent and reducing agent. The same can be done by using electricity. When you connect it to anode and cathode, at anode oxidation takes place, at cathode reduction takes place. So same way, by using electricity or electrochemical way, we can prepare p and n-type doping materials. The same way, we also induce the doping by using photo high energy radiation. When you allow the high energy radiation on the metal, it allows the electron jump to the conducting band. In this case, positive and negative charges are localized over the few bonds. Like that, we can prepare p-type and n-type doped conducting polymers. Those are called doped polymers or doped conducting polymers or extrinsic conducting polymers. So what are the examples and applications? Examples you can see polyacetylene, which is prepared by the acetylene molecule, polythiophene, polyphenylene vinylene, polyphenol, polyphenylene, polyaniline. So if you observe all molecule having a conjugated double bonds, these conjugated double bonds are delocalized double bonds. The electrons are moving around the molecule. These are the basic concept, basic principle to conduct the electricity. So these are very good conductors, just like metals. How metals conduct electricity? These conducting polymers also conduct electricity, and they are relatively stable, just like normal polymers. So just like other polymers like bakelite, polyvinyl chloride. So like that, these are also very stable, relatively stable. That's mean they are stable, just like polymers. They are conducting, just like metals. So that's why we can replace the different metals in different fields by the conducting polymers. Why? Because they are just like acting like metals. They can conduct electricity. They are also relatively stable. They are used in electronics, batteries, sensors, microelectronic devices. So polypropyrrole and polyaniline are currently used in production of metals as anti-corrosive coatings. We already discussed in the corrosion. When you made a coating, you can avoid the corrosion of the material. So these polymers can be used to avoid the corrosion of the different metals. In the medicinal field also, conducting polymer can be used to produce to production of artificial muscles, biosensors and drug control releasing systems. So there is so many applications of conducting polymers is there. So this is a short video about the conducting polymers and biomedical polymers. So thank you for watching.